All right, folks, I wanted to tell you a little bit about some of the other boards that we use in physical computing, different kinds of multiprocessors, and why we might use them for different tasks. And I'm going to start with the Arduino family of boards. And I'll just say up front, I am not like officially sponsoring any of these boards. I have no affiliation with any of these companies that make these products. I'm just showing you this for your own reference based on some of the material that I have used myself in the past. So looking at Arduino, the Arduino Uno is one that you've been reading about in the textbook. These are kind of ubiquitous in the physical computing world. They're actually kind of old at this point in time. They use a Atmega 328P board chip. That's this chip here. That's like the brains of the board. And they give us a lot of things that we want to do with a processor, and they're reasonably affordable, which is part of the reason why they're popular. They're also popular. I said it's old. It's been around a while, but that also means that the community behind the Arduino, and particularly the Uno, is huge. So if you get onto the forums for Arduino, you'll be able to find a lot of other people working with this board. They can be helpful when you're trying to troubleshoot something. So the Uno board has 14 digital input and outputs. It's got 6 analog ins, and because of this kind of weird form factor that's been with Arduino since the very beginning, actually, even before the Uno board, we can expand it with shields, and I'll talk about shields in a little bit. The Arduino Nano is very similar to the Uno. It's also the Atmega 328, but it has more pins. It's got it has 22 digital input and outputs, 8 of which can be analog ins. It's breadboard friendly, so it's got header pins here instead of the female pins that the Uno has, and they're in a regular 0.1 inch row on either side, so you can plug this directly into a breadboard and go from there. So for some things that might be easier to work with, it's also much smaller in footprint than the Arduino. It uses USB. It's not USB micro. It's the other USB. This one uses the big USB. So that's a consideration too. Then the other mainstays in the Arduino family are the Leonardo and the Micro. I'm going to talk about these at the same time because the only real difference between these two is the form factor, right? So the Leonardo is the same size and shape as the Uno, except that it uses micro USB. Whereas the Micro, again, is that breadboard compatible board, so you can plug it directly into a breadboard. Both of these use a 32U4 chip instead of the Atmega 328. This is nice because it can function as a keyboard, mouse, or a MIDI interface to your computer. The Uno and the Nano need a USB interpreter chip, which is here, to communicate with the computer. So they can't replicate. They can communicate, over serial, but they can't replicate the you can't make your own keyboard with an Uno without some other kind of intermediary software. Whereas you can have a Leonardo, connect some buttons, and have that be okay, when I push this button, it means the W key is being pushed. That's possible with Leonardo and Micro. What else about this? There's slightly more pins on these than the Uno. You got 20 digital input output, 12 analog in. So that can be nice too. If you're working with a lot of sensors, you might want to go with the Leonardo or the Micro. All of these work at 5 volts, which is normal USB voltage. That's fine. There's most of the shields are going to work at 5 volts. A lot of sensors work at 5 volts, but we're starting to see a trend in the industry towards 3.3 volts. So I don't know how much longer 5 volt will be the default currency of voltage for microprocessors. Also, They have 32 kilobytes of flash memory. That's like how much code you can store on there. It's not a lot. So if you get into more complex things, you start using larger libraries, you're going to have to look elsewhere for a microprocessor. And typically these are around $20, $25, depending on where you're getting them. There are tons for both the 328s and the 32U4s. There's tons of knockoffs available out there on different online retailing sites. But the quality often relates to the price. So like, can you pick up a Nano somewhere for less than $7? Probably. But often where the producers are saving money is in that USB communication chip, and so sometimes you'll have problems there with the driver. You'll need a different driver for some of the imitation Arduinos. So then let me talk about shields now too. So shields are a way to extend the capabilities of the Arduino, because the Arduino, unlike the Circuit Playground, it doesn't have anything built in. It doesn't have, beyond the like one status LED, it doesn't have any NeoPixels built in, it doesn't have any sensors built in. But you can add these shields to it. So here's an Arduino, and here's a shield, and the shields just plug right in to the Arduino like that. And you see that most of them have these like stacking headers. So they've got pins on the bottom, male pins on the bottom, and female pins at the top. So you can keep adding these things on top of each other and make like a super Arduino that's like a brick with shields. You do want to check to make sure that some of the shields will use particular pins for some kind of communication protocol. You want to make sure that each shield is using unique pins so you don't have any weird data overlaps there. But that's the basics of how the shields work. So what can you do with shields? Like this one I was just showing you is an audio processing shield. So you can connect speakers here. There's a 3 watt amplifier here, a headphone jack if you want to do headphones, an SD card slot so you can have audio files, which are usually pretty big, certainly bigger than the 32 kilobytes of memory that this has. So you store your audio files on here, and then you can send commands from here to here, telling it which of those audio files you want to play. And then it will play over either the speaker or the headphone connections there. So that's pretty neat if you want to work with audio on your Arduino. There's even a possibility to add a microphone here. This one is a motor shield. So this shield lets you connect either 2 stepper motors, one on each side, or I think 4 like regular motors. And you need to do that because motors usually consume a lot more current than the Arduino can provide on its pins. And so it has a separate power connection here where it would have its own 5 to 12 volt motor power supply. So depending on what motors you connect will determine how much voltage you want on that power supply there. And those are they're separate from the power that goes to the Arduino. So the Arduino will still need power from USB or its barrel jack. And then it gives you this nice, they had some leftover space on the shield, so you've got a little prototyping area there that's just a regular perf board, so if you have other components you want to connect, you can solder them in there. Which is kind of similar to this one. This one is entirely proto. It actually doesn't do much on its own. It's got an extra switch here, I think, and an LED, maybe 2 LEDs. But beyond that, it's all prototyping space. And you can see that half of it here, this is similar to how a breadboard works, where it's got like positive and negative rails in the center and on either side, and then a couple of these rows are connected, not the whole way, but some of them. So it makes it a little easier to work with some components there, and then you've got some open space over here. So that's just a handy thing to do. If you're working on a small circuit and you want to be moving fast, you can just get one of these proto shields and you're good to go. You don't even need to work with the breadboard then. I think there's even a little sticker mini breadboard you can stick on here if you want, and you can jump then to your pins through the female outlets here. And then the last one I've got to show you is a Wi-Fi shield, so you can add Wi-Fi capability to your Arduino as well if you so desire to do that. Yeah, so that's one of the really neat things about Arduino, is being able to expand it with these shields. I will add, though, that a lot of the newer microprocessors have a lot of what you can do with these shields built into them already. So, for instance, like the Wi-Fi, like a number of microprocessors now come with Wi-Fi built in, which makes this kind of superfluous. And trying to use a normal Arduino with Wi-Fi, I actually wouldn't recommend at this stage, because there are other chips that just do it more simply than trying to get the Arduino and the Wi-Fi to work together. So these are the kinds of things you want to think about when you're selecting the technology that you're going to use with your projects. So speaking of other boards, let's look at a few other companies who are making microprocessors. One of them is Adafruit. She's got her own line called Feather, and these are great. These are really nice boards too. They are all kind of in that Arduino nano form factor, where they're smaller. You can usually mount them on a breadboard, and she's just got so many different chipsets and options. It's a lot to kind of like weed through. You kind of have to like know what you're looking for. So I'm going to show you a few of them. Hopefully, will help you out with that. These are also around $20 each. And the cool thing about these is, unlike the Arduino Nano and Micro, she also makes shields for them, which she calls wings. So you can stack these little chips up to increase the functionality of them even further than what might be on there. Some of the differences are that they usually operate at 3.3 volts. You want to double check what voltage these ones operate at. And almost all of them have this built-in li-poly battery jack, so you can very easily run these off of battery power. And there's also the battery charging circuit on the board itself, which is fantastic. So unlike the CPE that can run off a battery, these you can connect the battery, and then if you connect the USB, it'll charge the battery too. So that's really super. It saves you from having to disconnect the battery to charge it, or have some other routine for charging your batteries on these small boards. So let's look through some of these on here. I want to start with one of the older ones, actually. Here we go. Here's a Bluefruit 32U4. Here's a LoRa radio 32U4. So these 32U4 boards are the same chip, that 32U4 chip that's in the Arduino Micro. So you can program these with the Arduino IDE, which is fantastic. Otherwise, the specs are very similar. The pin options are slightly different, but you can see what she's done here too is added some stuff to these. So like this one has a radio built in. This one has Bluetooth built in. So if you want some of these communication mechanisms built into your chip, you can do that. Here's one that has just the bare bones 32U4 with a little prototyping area. Here's the 328P one, which is like the normal Arduino Uno. So she's got a ton of options here. Some of the newer ones, what else? So she's also made some of these with the M0 chipset. That's the same as what's in the CPE. It's the ATS AMD 21 ARM Cortex. It's got 256 kilobytes of flash. That's significantly more than like the Uno or the Leonardo. 20 GPIO pins, 12 of which can be analog in, 1 analog out that you could use for audio or something like that. And she's made this circuit Python language so that you can program these boards with Python or with Arduino, which may be advantageous to you. I think up here at the top, I think these are like in chronological order. She's got the M4 one. Here we go. With prototyping space. That's the newer version of the AMD chip. It's the AT-SAMD 51. It's got 512 kilobytes of flash. And then you see a lot of these ESP ones. The ESP32 chip is really impressive. It's a Wi-Fi chip that you can also program. It's got 520 kilobytes of flash. It's got 10 capacitive touch inputs available through the pins, 12 analog ins. It's dual core, the 32 one, which is amazing because it lets like one core take care of the Wi-Fi protocol stuff while the other core can run your programs. This ESP8266, I believe, is single core, and you can sometimes run into problems between the Wi-Fi and the programming on there. That said, the ESP32 one is still kind of in development, so you have to know a little bit more what you're doing with it. And I'll add too that as much as I like Adafruit's stuff, that ESP32 chip you can get for like $7 on eBay or somewhere else, and program it with the Arduino IDE the same way, just with a different board extension library. But it's a very worthwhile chipset to know about if you want to work with the Internet of Things. All right, let's look at a couple more boards. Raspberry Pi, you may have heard of. Famously, they made a computer for $35. It is almost a fully functioning computer. They're on the version 4 Model B now, and this thing has got 2 HDMI jacks, 4 USB ports, Ethernet, Wi-Fi, headphone jack. It even has these special connectors for like a dedicated Raspberry Pi camera and dedicated Raspberry Pi display, and it's got all these GPIO pins that you can program with too. Now, Pi natively is just digital in and out. It doesn't do analog, but you can get other chips to give it analog capability. Similarly, the audio out is like very low fidelity, but you can add high fidelity audio to this. In Pi, they call it hats. So you get a Raspberry Pi hat, an Arduino Shield, a feather wing. They all have their own lingo, but most of these boards are expandable. What else can I tell you about Raspberry Pi? The new one, the Model 4, you can choose how much RAM you want to have, so you can get 2 gigabytes, 4, or 8 gigabytes of RAM. And you can do like normal computing with this. It runs Linux, comes with like open source word processor and web browser. It is slow. It's definitely slow. It's like going back to the 90s in terms of speed, and you can't do everything on the internet that you're used to. For instance, like Netflix videos won't play on the Raspberry Pi. But it's pretty neat. You can choose how much storage you want because it's got an SD card underneath, and that's like the where the operating system and all your files live on an SD card. And when if you want to write your own code, like to take advantage of these GPIO pins, you can use Python or processing, actually, which is a sort of like cousin to Arduino for computers. One thing to be aware of is that to power these boards, you do need a lot of amperage. They operate at 5 volts, so you need a 5 volt power supply, but you need at least like 2 amps or more to keep these things from browning out. And you don't want to do that because if they like lose power suddenly, you can damage the SD card and then corrupt your file system. They have still available some of the older ones. I particularly like the Model 3 B Plus because it has a regular sized HDMI. It only has one HDMI, but it's normal size, so you can use any kind of cable. With this one, you need adapters. They've got this Pi Zero W2, which is great if you're doing something headless. It also uses a tiny HDMI and even tiny USB ports. but if you're running something headless, like you don't have to worry about the adapters. It has Wi-Fi too, and Bluetooth, and it's like $10 I think for this one. So that's pretty compelling as well. This new thing, the Pico, I have not used, but it sounds like they are competing with like the Adafruit Feather M0. With this, it uses the same chip as the M0, but they're getting rid of these for $4 versus 20 over at Adafruit. So that's significant. Okay, let's keep going. I should say then, like, why would I use a Raspberry Pi over an Arduino or a Feather? I specifically, if I wanted like an embedded computing system that was kind of low power but it still had graphics, like I wanted to run something on a monitor, Raspberry Pi connects to HDMI monitors, so that's one thing. If I'm doing a project with sound, I'm probably gonna go Raspberry Pi because it works with sound. It's just easier to work with sound on a Pi than Arduino, where you need a shield or a bunch of other stuff that, like an Arduino plus the audio shield, is going to cost more than a Raspberry Pi by itself, right? So there's some economics involved too. Yeah. Or again, if I want to do some internet stuff, I might go with Pi because it has Wi-Fi and Ethernet built in. Okay. Another board that you should be aware of, this is like a real basic one, but the Makey Makey is fun. It is not really something you program. It is an alternate kind of keyboard input. It has a D-pad, which is like your arrow keys, spacebar, and mouse click. And then it's got a few other down here. I think this might be like WASD. And alligator clips. And you clip the alligator clips to the board, and then anything conductive, Play-Doh, bananas, foil tape, it turns that conductive thing into a capacitive touch sensor. So then when you touch it, it's like you're hitting that key on the keyboard. So it's a very fast way to do like weird prototypes. If you want to make some weird playful stuff, Makey Makey is great for that. And there's dozens of it. I've kind of like scratched the surface here of some of the bigger names in microprocessor design. There's tons of other stuff out there depending on what you want to do. It warrants some research, especially around machine learning. Now there's a bunch of boards. I think IBM and Sony and Microsoft all have their own boards specifically for machine learning applications. The last one I will show you is the Bella board, which I have not used myself, but I have seen a number of people use it, and it's quite amazing in what it does. Bella is actually, it's like a cape, which is like a shield, for a Beagle bone board. Interesting things about it is it has an onboard web-based IDE that you program it with. It has built-in stereo amplifiers because this board was designed specifically for audio applications, for like audio physical computing applications. And the amazing thing about it is how fast it is. It works at audio rate, which is just insanely fast. It's like almost zero latency. And so you can see, like, in terms of like MIDI processing on a desktop computer is slower than Bella. So that's why this board is popular for creating new interfaces for musical expression and other things like that. So again, that's my overview of boards for physical computing. If you have any questions or want recommendations on boards for projects, I would be happy to talk about what your like system requirements are and how to find a good board to meet those requirements.